students, today's lesson is about theoretical probability. And if you look at the top of your packet here, theoretical probability, we're going to define it. It tells us what should happen in an experiment. All probability values range from 0, an impossible value, or an impossible event, to the number 1, which is a certain event. For example, the probability of getting a number when you roll a regular die is 1. You're certain to get a number. The probability of getting a 7 when you roll a number cube is 0, because there is not a 7 on a regular number cube. Probability of getting an odd number would be equally likely, which is 1/2. So you see that all probability values are between 0 and 1. If it is likely to happen, then your probability is closer to the number 1. If it is something that is unlikely to happen, it's closer to the number 0. To find the basic probability of any event, we are going to write our answers as fractions. And this fraction is going to be the number of desired outcomes, what it is that we want, over the total possible outcomes altogether. So let's take a look at a few examples where we are going to be looking in a container that has 3 green, 1 red, and 4 black jelly beans. Without looking, we're going to choose a jelly bean from the container, and we're going to find each probability. Let's express our answers using fractions, decimals, and percentages. The first thing that we need to do is find the total number of outcomes in our bucket or our jar of jelly beans, which is 8. 3 plus 1 plus 4 is our 8. Next, when we write our answers using fractions, for the red jelly bean, the number of desired outcomes is 1 over 8. And as we just did a warm-up recently regarding fractions to decimals to percentages, that is the decimal 0.125 and the percentage is 12.5%. For a black jelly bean, I should use a black marker. For a black jelly bean, there are 4 out of the 8 jelly beans that are black. It's not necessary to reduce your answers unless it says so in probability. Our decimal will be 0.5, 0.5, and as a percent, our answer is 50%. Lastly, if we were to choose a purple jelly bean, we look across what's in our container and there are no purple jelly beans. So we would have 0 as our fraction, 0 as our decimal, and 0%, which, if you recall, is called an impossible event. For our next examples, we are going to pull out of the container red or green, probability of not getting a red, and probability of getting a black or a red. This or next to the little stars, for example 1 and 3, means that we are going to add the amounts of those marbles. So in order to find the probability of red or green, we're going to add the red jelly beans plus the green jelly beans. So my little brain cloud would be to have red, there was 1, green, there were 3, so our probability is 4/8. And again, we're going to express our answers as fractions, and it's not necessary to reduce unless it says so in your directions. Probability of not getting a red marble means that you're going to either get the 3 green you will either be getting the 3 green or the 4 of the black ones. Therefore, your total probability is 7/8 for not red. The probability of the black or the red, and again, your little brain cloud of work, there were 4 black jelly beans, there was 1 red jelly bean, and so then we had 5/8 for the probability of black or red. This middle example here from above with the words not, that is called a complement of an event. And by the way, the sum, if you were to add the probabilities of an event with its complement, you will get a certain number, and that number is 1, a certain event. So let's try it here with our probability of red followed by probability of not getting red. Oh, I'm so sorry, we got too far along here. My orientation is off on my machine here. There we go. The probability of getting that red jelly bean we already discovered was 1/8, plus the probability of not getting a red jelly bean from up above was 7/8. Well, we all know that any number over itself is the number 1. So that is a certain event. That is the sum of the probability of an event and its complement is going to be 1. Feel free to pause the video at any time to catch up on the writing of the fractions or the definitions. And let's try a couple more examples of probability of basic simple events. We're going to be doing questions 1 through 7, and as you go through numbers 1 through 7, please read the directions and record your responses in the Edpuzzle videos. You spin a spinner numbered 1 through 10. Each outcome is equally likely. Find the probabilities below as a fraction, a decimal, and a percent. And your choices will be listed in the Edpuzzle world. Be sure to read carefully and look at the choices before choosing. You will be doing question 1, followed by question 2. You'll be doing question 3, question 4, remembering that multiples are when you repeatedly multiply your number. 4 times 1, 4 times 2, 4 times 3, 4 times 4. Followed by 5 through 7. This time your experiment will be about some marbles, and you're going to draw 1 marble at random. And please find each probability, but here you may just do a plain old fraction answer, please. And again, you do not have to do them in lowest terms. Please answer 5, and 6, and 7. You can see that there are more questions on this page. This is going to be the first part of your homework assignment. Tonight you are going to be finishing page 2. You will be finishing questions 8 through 17 for your homework. And now together I would like us to advance to the next page, where we will be talking about experimental probability. Experimental probability is very, very similar to theoretical, but theoretical shows us what should happen if we roll a number cube, but experimental probability is finding probability through an experiment or an observation or something that someone has already gathered data regarding. Your denominators are still the total number of outcomes, But in this case for experimental, it's how many times the person performed the experiment. And the numerator value is still your part. It's how many times did this particular event occur, whereas instead it was favorable outcomes or what should happen in theoretical. We're going to look at the results of this table here as a couple examples. Experimental and theoretical are very similar. It's just that one probability is based on actual data. Here is a table that shows the results of spinning a spinner. And this person performed the experiment 50 times. So that will be your denominator in each of your examples. And then based on the results and the probability, let's find the probability of getting green. So we are going to look over at our table. We're going to write in the numerator the number of times that green occurred over the total number of trials, and that's it. It does not say that we need to reduce or express as a fraction or decimal or percentage, so we get to just leave it at 18/50. Number 2 goes on to say, based on those results, how many green spins would you expect to occur if we were to perform this experiment 300 times instead of just the 50 times? Well, we are going to be taking 18/50 of 300. You could also say that you are going to take 9/25 of 300. And it says, based on the results, about how many, and it's going to be approximately 108 spins should be green. Number 3 goes with a new spinner. It says, what is the theoretical probability of spinning green? Well, I see 2 sections that happen to be green. So that's our desired outcome. However, when we talk about how many outcomes altogether, this section for red is actually taking up 3 spaces. So between everything on the spinner, we should expect that 1/3 of the time, in theory, we should be getting green. So based on this theoretical probability, 1/3 of 300 spins would be about 100 spins would turn up green. So if we were to look at this theoretical probability versus our experimental probability, we've got the number 108 versus 100. They're pretty close. In fact, the more you perform an experiment, the closer your probability will be to the theoretical probability. So if we were to do this 200 times, 300 times, 400 times, 500 times, we will be getting closer and closer and closer to 100 times getting the green. So the more you perform an experiment, the closer the experimental probability gets to the theoretical probability. Whoops, sorry, the theoretical. Take a moment to write that expression down. The more you perform an experiment, the closer the experimental probability is to your theoretical probability.